So this is a little bit of a review. We've actually talked about how to do this already. However, for reasons I don't understand, the great lords of the math world decided to have different names for the exact same thing. So you might look at this and say, what is this talking about? Finding zeros? Finding zeros of a linear function? Well, it turns out zeros are just the same thing as x-intercepts. So if they ask you to find the zero of a function, they're asking you to find its x-intercepts. And you don't have to remember these other words now, but in the future, in your math career, you'll also learn that they're sometimes just called solutions, they're sometimes called roots, but they all mean the exact same thing. So a linear function is a function for which the graph is a line. That's why it says line at the beginning. So values of x for which f of x or y is equal to 0 are called zeros of the function. So there is a reason they're called zeros. It's because when the function, which is the y value, equals 0. But we've done this before when we're finding x-intercepts. So to find the zeros, you plug in 0 for either the f of x or the y. It doesn't matter which one. You'll only see one or the other in a problem. But like you look in here, you need to make sure you understand f of x right here means the exact same thing as this. There's no difference between the two. They mean the same thing. Then you'll solve for x. Then you rejoice because you're done. Step 3 is very important. So on example 1, we plug in 0 for f of x. And now we want to solve for x. So I'll add 8 to both sides. Then divide both sides by 2. So the 0 of this linear equation is 4. It occurs at x equals 4. Number 2, we plug in 0 for the y. We subtract 3. Divide both sides by 3. We get that the 0 occurs at -1. Number 3, we plug in 0 for the y. And we want to solve for x, and it's truly up to you. It doesn't matter if you want to move the 4x over, the 16 over. I'm going to choose the 4x, but it doesn't have to be that. Then I'll divide both sides by 4. So this equation has a 0 at x equals -4. Number 4, we plug in 0 for y. And I'll subtract 3 from both sides. Okay, now I want you to think through this with me. This is 1/2 times x. So you can certainly get the correct answer by dividing both sides by 1/2. And there's nothing wrong with doing that. But I also want you to think multiplying by 1/2 is the same thing as dividing by 2 because you're halving the value of x. This is also cutting in half the value of x. So multiplying by 1/2 is the same as dividing by 2. So another way to approach this is instead of dividing by 1/2, an equivalent thing to do is to multiply both sides by 2. Because that's 2 over 1. So then the 2's would cancel. 2 times -3 is -6. And just showing you how this cancels even if you have the fraction form, still the 2's would cancel. So we get that -6 is equal to x. So this linear equation has a 0, meaning it crosses the x-axis at x equals -6. Okay, number 5, we replace the f of x with 0. We get negative 7. Huh. Well, this has no x. Step 2 says solve for x. But there is no x. Well, if you look here, is it ever possible for 0 to equal negative 7? No. So it turns out this line has no 0. So just to help you understand how that can be, this is actually a horizontal line. So there's the x and y axis. This would be a horizontal line down at negative 7. So because it's a horizontal line, it never crosses the x-axis. So it is possible for there to be no 0. When there's no x value, there's no 0. Or x variable, I should say. So this one, we plug in 0 for f of x. Subtract 6 from both sides. We multiply both sides by 5. Negative 30 equals 2x. Let me pause there and make sure you're following me. The reason I multiply by 5 is this is dividing by 5. A fraction is doing two things. It's multiplying by the top number and dividing by the bottom number. So I multiplied by 5 over 1 because then I had 5 over 5, which reduces to 1. Now we're multiplying by 2, so we do the opposite and we divide by 2, and we get negative 15 is equal to x. So that's where this line hits the x-axis. That's where this function is equal to 0. And just a reminder, the point is that x-intercepts, aka zeros, tell you how much of the y value you have. No, oh man, big typo here. It's how much of the x value you have when y is equal to 0. Gosh, I gotta make sure I correct that. So zeros of a function tell you how much of the x value you have when y is equal to 0, which we talked about that in yesterday's lesson, but just a reminder that what x-intercepts tell you is the same thing as what zeros tell you.